Okay, now we're going to go through the security automation overview, also located in my repo. If you go down to the CIC automation security scan markdown file, you can actually see all the prerequisites as well as a high-level overview of the architecture for the security scanning YAML. So first and foremost, if you're going to clone or fork this repo, you're going to need to have Docker, of course, in your local environment. You'll also need to have a Docker Hub account because your credentials and personal access token are going to be required. I've also added a stage for Slack notifications. This is optional. If you don't happen to have a Slack account, you can simply remove those stages from the workflow. Now, if you scroll down a bit further, you'll actually see the high-level architecture. We can kind of walk through this. Now, the pipeline is actually going to start with an initiating event. So typically, a developer will commit code to the main branch. In an enterprise-level environment, you'll probably have feature branches or different environment-level branches. For the purposes of this project, we have everything going to the main branch. This will initiate the GitHub action trigger, which will actually start the process. And then from there, we're going to go into the first gate, which is going to be the static analysis of the source code. This happens before anything else gets built, and we're going to use Trivy for that. The second stage is going to be a container scan. So Trivy can actually do container scanning as well. It means it can identify critical or low-level or medium-level vulnerabilities, and we can design it in such a manner that it can stop the pipeline if one is found. The next stage is going to be dynamic testing. So we'll actually recreate a live environment within the pipeline so that it can be tested with OWASP live attack. So this is another check we can use to test the actual application as it's running. Then next, I actually have my reporting phase. In this stage, I've incorporated some reporting features so that we can get a report artifact that contains any information about critical errors or vulnerabilities that may have been identified in any of these previous stages. And then I've also integrated a Slack alert. I've added my Slack webhook to this stage so that I can be notified via Slack if that's your preferred channel of communication. And this just notifies you of a critical event being found. So if there was an exit code that happened, or if there was a high or critical alert, the stage would cause the entire pipeline to stop. Okay, so that's the basic outline, and then we'll get into more details about the actual YAML itself in the next chapter. Okay, now we're going to walk through the security scan YAML and get an idea of what each individual stage does. And starting here with this trigger and permission stage, we've defined the triggering action that's going to start our pipeline. I have it set up to where a push to the main branch is going to initiate the workflow. I also have a second event defined for a pull request to the main branch. Now, since this is just a demonstration, I have everything going to main. However, in an enterprise environment, you typically have multiple branches, multiple environments, and there would probably be a lead developer that would approve the pull request and merge it to the main branch. So feel free to edit these lines of code here or perhaps comment them out as needed. These are just here for demonstration purposes. Okay. Now, what GitHub Actions is going to do is create a runner, which is a temporary VM, and we're going to assign it permissions, read and write, so that it can perform the actions it needs to do to facilitate the pipeline. We only want to give it just enough permission to do the job that it needs and nothing more, so that we follow the principle of least privilege. Now, if we scroll down a little bit, we're going to go to the static code analysis portion. Now, our first security gate is going to go through Trivy, which provides a file system scan, as you can see here for FS. The source code for the application is going to be located in the applications directory. So Trivy will scan the source code and detect any hard-coded secrets, insecure libraries, or dependencies, demonstrating our shift left philosophy. And the next stage is going to go down into container scanning. Okay, so we can actually use Trivy as well here to do an image scan. So the familiar Docker build command is used here to actually create an image that Trivy can then review for critical errors. And in the event that there is a critical error, it will exit with code 1. Now, if we go down a little bit further, we're going to move into the dynamic analysis. So GitHub Actions has the ability to run DAST or dynamic analysis of the application. So as you can see here, Docker, the familiar Docker run command is being used. So we're actually going to spin up a container in the security scan phase, and we're going to run a test with OWASP so that it can perform a scan and check to see if there are any vulnerabilities affecting the application, which is very important because OWASP is the Open Web Application Security Project, and it maintains a robust list of the most pressing web application security issues. So you definitely want to have that baked into your pipeline. Next, I've set up a stage for reporting. Okay, so as a result of the ZAP analysis, there's a GitHub action that actually allows you to produce a report in either HTML format or MD format. So I have it set up so that both artifacts will be created upon completion. And then I have a custom step here, and this is for a dashboard. Now, if you're familiar with GitHub Actions, you know that it produces a very robust set of logs. By adding this code right here, I'm able to produce a very user-friendly dashboard that summarizes the events. Actually, let me show you an example. If I go up to the GitHub Actions tab at the top, I can show you a run that I've done previously. Let's pick this one. And if you see right here, there's a very user-friendly, easy-to-read summary that just gives you an overview of all of the vulnerabilities found. So if you want to incorporate that into your pipeline, this is a very good way to do it. Now, if we go back, we can continue going through. All right, now the cleanup phase. So this phase is basically for basic hygiene. We want to clean up the container regardless of what happened and regardless of the outcome. We want to make sure that our environment is clean and we remove the test containers. I have a Slack stage as well, and this is for notification purposes. I have a Slack account, and I provided the webhook URL in the secrets portion in GitHub so that the two can be connected. If there are any vulnerabilities discovered or any critical issues, I'll be notified via Slack notification. Okay, so this is my Slack account. I've set up a channel that's specifically dedicated to security alerts. These alerts are tied to my GitHub Actions workflow for my security scan. In the event that a vulnerability is detected, it's actually going to alert me, and it's going to provide the actual link to the GitHub commit in which the vulnerability was found. So if I click on one of these commit messages, it'll show me in GitHub exactly where the issue occurred, so I can refer to it very quickly. So I highly suggest that you have some sort of alerting or messaging system built into your pipeline as well. Okay, now that we've walked through each stage of the security scan workflow, we can now do a live run of the pipeline and walk through the results in real time. So I've made a small change to my workflow YAML here. I'm going to demonstrate pushing these changes to GitHub so that we can initiate the pipeline. So I've gone ahead and made a change to a file here, and we're going to do git add, and we're going to go ahead and upload our revised YAML file to GitHub. And we're going to give it a commit message here. We're just going to say security workflow test. Okay. And then we're going to push origin main. Perfect. Okay, now I'm going to go ahead and pull up my GitHub Actions workflow. And we can see that a new build has been initiated. So I went to the GitHub Actions tab at the top. You can see right here, this little spinning wheel indicates that a workflow has been initiated. If we click on the title right here and we click on this panel, we can see the build start to run. So it's already started. Okay. And if we continue to watch, we can see that we are in the build Docker image for scanning stage. We're building the application into a container. The image is going to be tagged scan as scan. And then it's going to create an image, not the production image, but just a test image for security validation. Okay, it looks like it's going ahead and move to the run Trivy container scan. Trivy is actually auditing the image and it's providing us with its results. It's now moved to the DAST scanning, so the image scan will now be spun up in a live running container on port 8080, and we'll give it a few seconds to initialize, and then it's going to start with the ZAP baseline scan, and it has. Okay, this is the dynamic analysis phase. ZAP is trying to attach itself to the live endpoint, and it's going to probe and look for issues and alert us if there's any major problems. Okay. Okay, the baseline scan stage typically takes a little while to complete. In this instance, it took about 3 minutes, which is not unusual. If we scroll down a little bit further, we'll see that the stage completed and it moved on to the ZAP report stage. If you remember from the workflow earlier, I mentioned that this will produce a artifact. Basically, it's a report that is both going to be in HTML format and Markdown language format. So these two reports were built into the workflow. So if I click on the URL right here, it'll actually start downloading the report for me. Okay. Now, if we want to take a look at the reports, we can go to this window right here. This is the downloaded and unzipped set of files. Here's the Markdown language report, and here's the HTML format. We'll click on the HTML one just so we can see what the report looks like. It's very polished. It lets us know how many issues we had. We had no high-level alerts, 3 medium, 6 low, 1 informational. If you want more information about them, you can actually look down here. So it's very detailed, very granular. This is exactly what we'd expect from that stage. And I will go ahead and close this out. Now, if we continue down, we'll see that the cleanup stage actually occurred. It removed the test container, and it generated the dashboard. Now, there was a custom stage that we added to our workflow that produced a very user-friendly, human-readable dashboard. So we'll take a quick look at that. If I go up to a new tab, and I go to Actions, and I look at this most recent run, we can see right here that the dashboard was created. So this is just a high-level summary of everything that occurred. It just lets us know at a high level if there's any major vulnerabilities or issues. Okay, so that's very helpful. If we continue down, we see that the cleanup completed and the code was checked out. Anything else notable here? This is just a deprecation notice. This is telling us that in the future there's going to be an action that's deprecated. Doesn't really apply to us at this stage right now. So if we go all the way back up, we can see that the job has completed, and this is, of course, is the error we just looked at the very bottom of the workflow. Okay, now that we've actually seen the pipeline work, we've seen the security scan process in action. What we're going to do is we're going to intentionally make a change to the code so that it's less secure, and we want to see how the pipeline behaves when there's a more critical issue. So I'm going to go and change the actual Docker file so that we're using a older image of Golang. So 1.23 is what we're going to use in this test run. I'm going to go ahead and save, and we're going to go ahead and add the Docker file. All right, so in this upload, we're going to have git add, and we're going to use the infrastructure directory, and we're going to go ahead and reference the Docker file. Okay, we're going to make a commit, change Docker file image. Okay, and we're going to go ahead and push. Okay, so in just a few moments, we'll be able to see another workflow. Okay, so as you can see here, the security pipeline has started. We're going to watch the process, and we're going to see if it does detect the change and alerts us to any potential critical errors. Okay. Now, as you can see, that run was a lot quicker than the previous one. And if you notice, we have a critical error. Okay, so it actually went through the first few stages. It set up the job, checked out the code, ran through the static code analysis. But once it got into creating the Docker image, this is where we run into trouble. As you can see down here, once we got to the container scan, it provides us a table of vulnerabilities, but it does show us that we do have a critical error. And the way we designed our pipeline is such that when it hits error code 1, then it's going to exit. And if you notice, none of these other phases actually completed, which is exactly what we wanted to see. Okay, so let's go down a little bit further and let's check out the security dashboard. So I'm going to quickly go back up to the actions folder. Okay, and I'm going to look at the most recent run. Okay, so as you can see by that little red X right there, that means it failed. And that's exactly what we wanted to see. It ran into an error and the process failed. Okay, so now I'm back in my Slack account. And as expected, this most recent vulnerability was in fact detected. I was informed via webhook notification, and the commit number was also identified. So if we want to do a little bit more research into this vulnerability, we can go back and check out the run workflow. The issue has to do with the container and the image that was used to create it. If you remember, we made some changes to the Docker file. We changed the Golang base image to 1.23, which obviously triggered some issues here. And if we click on this particular link right here, we'll get a little bit more information about the vulnerability that was found. Looks like it affects Golang. If you want to get an idea of the severity or the severity rankings, they're provided here in the Trivy documentation. You can kind of see the base score ranking and the severity. So ours was critical. It's in this high range, needs to be taken care of, obviously. And if we want to do a little bit more research, we can see that Go version 1.23.2 does have some common vulnerability issues. So it's probably a good idea to upgrade it. So it looks like our pipeline did a good job of recognizing this issue. And with just a little bit of research here, we can correct that. And we can go back into our Docker file and make the necessary change. Okay, now that we've walked through the vulnerability and the critical issue, we're going to go ahead and make the change back to our Docker file. So I'm going to go ahead and change the base image back to 1.24. I'm going to go ahead and save, and we're going to go ahead and perform git add. Here we go. And then we're going to go ahead and do a commit message back to 1.24. Okay. Okay, and then now we're going to do our push. And then we'll watch the build process. just a moment. All right, here we go. Okay, so we've initiated another build process. If we go back here and watch the stages in this next screen here, if we click here, okay, perfect. All right, so as we watch each stage, we'll see that we have a lot less vulnerabilities. We will have removed that critical issue, and the build should be able to continue past the container scanning phase onto a complete build. Okay, looking good so far. As you can see, the container phase passed through with no issues, so that's a very good sign. Okay, we're just going to let this run until completion, and then we'll come back and take a look at the end to see if there were any issues with the process. Okay, so as you can see, the build process completed. Just like last time, it took about 4 minutes roughly. And as you can see, we were able to get through to the report phase, the test phase, dashboard phase, Slack notification, the container scan, the vulnerability scan, checkout, and completion. Okay, so it looks like that change in the base image made a huge difference, and it removed our critical vulnerability. As you can see here, we've got our green check mark, which means we had a successful build. And if we go back and check in the GitHub Actions tab, we can see that our dashboard, just like it did before, shows passing and it also shows the warning. So we still have those 8 low-level vulnerabilities, but no critical ones. And also, the artifact that our report produced can actually be accessed here as well. So if we just click here, it's actually going to download that same zip file that it did last time. Okay. All right, so next what we're going to do is we're going to look at the build pipeline. We're going to walk through the CI YAML and figure out exactly what those stages do, and then we'll do another demonstration.